5.1 Absolute Extrema and the Extreme Value Theorem. First off, what is an extrema? An extrema can be defined as the largest or smallest point within a closed interval. For example, in this graph, there are three main points in the restricted area. There's the largest point and there's the smallest point, or the highest and lowest point. The high point that you see here would be the absolute maximum, and the low point you see here would be the absolute minimum. The absolute maximum would be the largest or the maximum point on a restricted function. It has to be restricted or else it wouldn't be the absolute maximum. The absolute minimum essentially is just the opposite of the absolute maximum. It's the lowest point of a function in a restrained area. Since I'm talking so much about closed intervals, let's go over what a closed interval is. Basically, it's just a restricted area that the function has to be in. Now, what if there are holes in the function? What would that be? Well, in this case, it would not be an extrema. So, how would we know what is and what isn't an extrema? Well, that leads us to the extreme value theorem. The extreme value theorem states if f, the function, is continuous on a closed interval a, b, then the function has both a minimum and a maximum on the interval. Let's take a look at this problem. On this graph, there's a closed interval, as you can see. And I'm just going to randomly draw this. So what's the max and what's the min? Well, as you can see, there's an obvious high and a low. So the high point would be the max and the low point would be the min. It's as simple as that. But what if you're lazy and you don't want to graph stuff every time? So how do we solve this algebraically? Well, there's about 4 steps to this process. Step 1. First, ask yourself, is this function continuous on the given interval? Do some basic algebra 2 and you can find whether this function is continuous on the interval or not. In this case, it is. Step 2. Find critical points. You may be asking, what's a critical point? Well, to find a critical point, you first have to find the derivative of the function. To find the derivative, I've got an example for you. Y equals ax to the b power. To find the derivative, you take b, multiply it to a, and then give x the exponent of b minus 1. That didn't make sense. Hopefully this one with numbers will help. I'll give you y equals 3x squared plus 6, and the derivative of that would be 6x, because you take the 2 down and multiply by 3, and 2 minus 1 would be 1, so that would be 6. So anyways, you set the derivative equal to 0, and then you solve for x. But say you get your answer and it's 2 and negative 3, but then the interval was 0 and 5. Negative 3 is outside the variable, so it's cancelled, and you don't count that. So your critical point is just 2. Step 3. Take the critical points plus the endpoints, and then plug them back into the original equation. Keep in mind that this is the equation originally given to you, not the derivative that you solved. Take the biggest answer and the smallest answer that you got from plugging it into the equation. Those 2 points should be your absolute maximum and your absolute minimum. Now let's solve a problem algebraically. I'll give you f of x equals 2x cubed plus 3x squared minus 12x plus 4 on the interval of negative 4, 2. Now we do step 1, which is asking yourself, is this function continuous? And it happens to be continuous on this interval. Step 2, find the critical points. That means finding the derivative, and the derivative of the function should be 6x squared plus 6x minus 12. You could simplify to 6 times parentheses x squared plus x minus 2. Set it equal to 0 and simplify some more, and you should get parentheses x plus 2 times parentheses x minus 1 is equal to 0, and you get x equals negative 2 and 1. Now check to see if these two numbers are okay on the interval of negative 4 and 2, and they are. Step 3. Plug the numbers back into the original equation. Remember, this is the equation we started off with, not the derivative that you solved for. Remember to also plug back in the endpoints, not just the critical numbers, to find f of negative 4 and f of 2. And then you solve, and then you get 24, negative 3, negative 28, and 8 as answers. Now we have 4 answers. So which one of these is the extrema? Well, the largest number is 24, so that should be the absolute maximum. And the smallest number is negative 28, so that should be the absolute minimum. Step 4. Take the largest coordinate, and that should be the absolute maximum. In this case, that would be negative 2, 24. And you take the smallest coordinate points, which should be the absolute minimum. And in our case, that would be negative 4, negative 28. There, now you solved the problem. If you need extra practice, you can always go down to the link and do the practice problems provided. I have also provided a written out answer key. Now go study and don't fail your final.